So this video is for Integrated 3. This is the Chapter 11 D-Day number 1. So on the first problem, we need to get a common denominator because we are going to be adding. So our common denominator is going to include an x minus 3 in the denominator and an x plus 5. So I need to multiply top and bottom of both fractions by whatever it is missing from that denominator. So on this side, I'm going to multiply by an x plus 1 on top and bottom. On this one, I'm going to multiply by an x minus 3 on top and bottom. So I'm going to end up having 5 times the quantity x plus 1 plus the quantity x plus 3 times the quantity x minus 3. And I'm going to be working that out. I'm going to end up with a 5x plus 5. And x plus 3 times x minus 3 is x squared minus 9. You can do that using a box or a diamond, or realizing it's a difference of 2 squares. And on the bottom, I'm going to have an x minus 3, x plus 1. I'm going to combine like terms. I'm going to end up with an x squared plus 5x minus 4 over x minus 3 times x plus 3. Now, we always want to make sure that we check to see if we can simplify the top by maybe factoring it and having it cancel with the bottom. So in terms of trying to multiply and get a negative 4 and add to get a positive 5, I am not going to be able to add and get a positive 5 when I'm trying to multiply and get a negative 4. So that is going to be our answer, okay, like this. Okay. Number 2. This one is multiply. I don't need to get a common denominator. I want to factor everything. So on top, that's going to stay at 10x squared. On the bottom, I'm going to get an x plus 2 times x minus 2 times, and then I'm going to have an x plus 2. And on the bottom, I can factor out an x and get an x minus 2. Now I want to see if I can simplify. So I have an x plus 2, x plus 2. Those are going to cancel out. I actually also have an x here that can cancel with one of these x's here. So I still have one x on top. And so my answer is going to be 10x over, and I'm going to have an x minus 2 times x minus 2, or I can write it as an x minus 2 quantity squared. And that's going to be my answer. For 3, I'm going to factor the top. The top is going to be a 5x that I can factor out, and I'm going to have an x minus 2. When I'm doing the bottom, you can do a box to diamond. I'm going to just set it up like this. I know it's going to be a 2x and an x in the front. I know I'm going to be trying to get a negative 15 when I'm multiplying, but I need it to add to a negative 7. Now, what I need to remember is whatever goes here is going to be multiplying with my 2x. And whatever goes, let me just kind of maybe change that color. So whatever goes here is going to be multiplying with my 2x. And whatever goes here is going to be multiplying with x. Okay. And I'm trying to multiply and get a negative 15. And then try to get a negative 7. So looking at this, I am thinking that I want a negative 5 here because that's going to multiply and give me a negative 10x, and then add 3. Okay, and then I am going to be multiplying by, and I'm going to factor this. Now, when I'm factoring this, it could be a 6x and an x, or it could be a 2x and a 3x. I'm going to see if it's a 2x and a 3x since I happen to have a 2x on bottom. Okay. So now what's going to happen is, again, let me just get rid of these. I am going to be trying to multiply and get a -3 and add and get a 7. But when I'm doing that, whatever is going to go here is going to multiply with my 2x, and whatever goes here is going to multiply with my 3x. So I am thinking that I want to have, it's going to be a 3 and a 1. And I'm thinking a 3 here because that's going to give me a 9, and I want that to be positive. And then a -1 here because that's going to give me a -2. Now, again, you can do box to diamond factor if you prefer. On the bottom, I can factor out a 25, and I'm going to be left with an x -2. So now I'm going to try to see if I can simplify anything. So looking at this, I have a 2x plus 3 and a 2x plus 3, so those are going to cancel out. I have an x -2 and an x -2, so those are going to cancel out. Now, looking at my number here, I have a 5 and a 25. So 5 goes into 25, 5, and I'm going to have a 5 left over. So when I clean this up, I'm going to have an x times 3x -1 on top. And on bottom, I'm going to have a 5 times x -5. And that is our answer. 4. On 4, I'm going to have a 2 over, and I need to factor this. This is going to be an x. I want to multiply to a -18 and add to a 3. So that's going to be an x plus 6 and an x -3. Minus, but I'm going to go plus a negative. Okay, and that negative is going to go on top. I'm going to distribute it after I do more math. So on the bottom, x squared plus 4x -12. I need it to multiply to a -12 and add to a 4. So I'm going to say plus 6 -2. So common denominator. Both of them have an x plus 6. Okay, so right now, this and this are covered by this. Okay, I also am going to need an x -3. So I'm going to put x -3 here. I'm also going to need an x -2. So I need to put an x -2 here. And so now I'm covered. Okay, that x -3 is covered here, and that x -2 is covered here. Okay, that's going to be my common denominator. So then I want to multiply by what they are missing. So this one here did not have the x -2. So I'm going to multiply the top and bottom by x -2. This one here did not have the x -3. So I'm going to multiply top and bottom by x -3. So now each of my denominators will contain an x plus 6, an x -3, and an x -2. Okay. So now on top of the first fraction, I'm going to have a 2 times x -2. And I'm going to put a minus here because I have a minus in front of my x -2 times x -3. So now I'm going to have a 2x -2 minus, and I'm going to put a bracket. And I'm going to work out x -1, x -3, thinking diamond or doing a box. So really, I'm thinking what multiplies, what does a -1 and -3 add to? And what do they multiply to? That's really how I'm doing that, but you can do a box or a diamond. On the bottom, I still have my x plus 6, my x -3, my x -2. So now I'm going to clean this up. And what's going to happen is I'm going to end up with, let me just kind of move this. I'm going to put it up here. Okay, I'm going to write it in pink so you can see this is where I am now. Okay, so 2x -2 minus x squared plus 4x -3, still over that denominator. I'm going to combine like terms. So I'm going to have a -x squared, a 6x, and a -5. over x plus 6, x minus 3, x minus 2. I'm going to see if I can factor the top. Okay, so what I'm going to just do is I could factor a negative out at the top, and I'd have an x squared minus 6x plus 5. I want to think, can I have anything multiply to a 5, positive 5, and add to a negative 6? And I'm thinking that that would be an x minus 1 and an x minus 5. None of those are going to cancel with the denominator. So I can just leave my answer as it is, okay? Because it's not going to factor to anything that's going to cancel with my denominator. On number 5, for something like this, when I'm looking at this, I'm focusing on this and this, but what I'm going to do first is from this, I'm going to need a 3x squared, okay? And so here's my 3x squared. From the other one, I'm going to need a 2xy. Okay, so I'm going to need a 2 because I don't have a 2. I don't need an x because I have an x right here in that x squared, so I don't need that. But I am going to need a y, okay? So again, the 2 is covered here, the y is covered here, and I have an x right there, so I don't need to add any more x's. So that's going to be my common denominator. So what am I missing? This one here is missing a 2y. So I'm going to multiply top and bottom by 2y. This one here, I'm missing a 3, I'm missing an x. And I'm missing a 3, I'm missing an x. So I am going to get a 10y plus a 21x. I'm going to actually clean up that denominator because that's really going to be a 6x squared y. That's really my common denominator. And I have a 10y plus 21x. I cannot simplify that any further. That is going to be my answer. On 6, I'm going to factor the top. That's going to be an x plus 4, x plus 2 of the first fraction. On the bottom, what multiplies to -5 and adds to a 4, that's going to be an x plus 5 and an x minus 1. Now, what's going to happen is when I'm dividing, I'm going to change it to multiplying by the reciprocal. So this right here is what's going to go up here on the top. And this right here is going to go on the bottom. Okay, so I'm going to factor this, and I'm going to get a 3 x plus 5. From the green, I'm going to get an x plus 2 squared or an x plus 2x plus 2. It's probably the easiest way to think about it. Now, I am going to see if I can simplify things from top and bottom. So I have an x plus 5 and an x plus 5. I have an x plus 2 and an x plus 2. And that looks like that's all I'm going to have. So I'm going to have a 3x plus 4 over an x minus 1 times x plus 2. And that is going to be our answer. 7, got to get a common denominator. So first, let me do that. Let me first factor it. So this is going to factor to 3 times the quantity x plus 3. 5x over, and that's a difference of 2 squares. So that's going to be an x plus 3, x minus 3. So I need to get a common denominator. Okay. So I am going to need a 3 and an x plus 3. Okay, because that denominator has that. Over here, I need an x plus 3, but I already have it. So I don't need it again. And then I'm going to need an x minus 3. I don't have that. So then I'm going to need an x minus 3. So again, now you see that from my second denominator, I needed an x minus 3. Here's the x minus 3. I need an x minus 3. Here's the x minus 3. So then what I'm going to do is I'm going to multiply by what is missing. So this one here was missing my, and I'm actually going to do this. I'm going to copy this. Okay, let's get rid of this. Okay, just trying to give myself some space. Let me just, okay. So what's going to happen over here is I was missing an x minus 3. So I'm going to be multiplying top and bottom by x minus 3. Over here, I'm going to be multiplying by an x plus, not an x plus 3, sorry. I am missing just a 3. That's what I'm missing. So now what I'm going to end up getting, okay, let me just move this. Okay, so what I'm going to end up getting, just want to rewrite this so you can see that was where my x minus 3 was. Okay, so again, my denominator, I had a 3 and an x plus 3 and an x minus 3. That was my denominator. I'm going to distribute and get a 2x minus 6 and a 15x. I'm going to combine like terms and get a 17x minus 6 over 3 times x plus 3 times x minus 3. And that's going to be my answer. On 8, I can't really factor my 25x squared y, but I can take a 5 out of this and get an x plus 2 times, I can take a 2 out of this and get an x squared minus 4, and that's going to be over 10xy cubed. Now, this x squared minus 4, that I can factor. That's going to factor to an x plus 2, x minus 2, okay? So let me just rewrite this. So I have a 25x squared y. I have a 5x plus 2 times 2 times x plus 2, x minus 2 over 10xy cubed. So let's see. I have an x plus 2 and an x plus 2. I am going to cancel one. Do it this way. I'm going to cancel one of these x's with one of those, so the square is gone. I can cancel this y, and now instead of having a y squared, I have a y cubed. Okay. I can also simplify. 2 goes into 10 5 times. And I can simplify further. I have a 5 and a 5 that go into this 25. So I am going to have, as my final result, on top, I have an x and an x minus 2. And on bottom, I'm going to have a y squared. And that is my answer. So on number 9, we want to factor the denominators to see what we have. So I'm going to have p plus 5 over p times p plus 1 equals 1 over p times p plus 1 minus p minus 6 over p plus 1. So this is kind of an application problem, a little reminder from integrated 1, but a little more difficult than integrated 1. In integrated 1, we learned how to fraction bus. So we want to multiply everything by something or some things that will get rid of each denominator. So I'm going to multiply, let me just put parentheses around this. I'm going to multiply every single term by a p and a p plus 1. I'm not doing it top and bottom. I'm not going to be trying to get common denominators. I am trying to cancel out. Maybe let me do it like this. I'm going to copy this. Okay. And I am going to times this by p times p plus 1, p times p plus 1, p times p plus 1. And I should have things eliminate. So this whole thing is going to eliminate this whole thing. And I'm going to be left with p plus 5 equals. And on the other side, this p times p plus 1 eliminates with this. And I get an equal 1. And then there's a minus here. And then here, this p plus 1 and p plus 1 cancel. And I'm going to be left with a p times p minus 6. So now I'm going to clean this up. So I'm going to get a p plus 6 is equal to 1 minus p squared plus 6p. We have a quadratic. You get everything on one side, 0 on the other. So I'm going to make sure that my p squared is going to be positive. So I'm going to take everything over to the side with the p plus 6. So I'm going to get a p squared, positive p squared. I'm going to subtract 6p, so I'm going to get a negative 5p. I'm going to subtract 1, so I get a plus 5 equals 0. Let me just double check my math here. So p minus 6, I got a p squared minus, oh yeah, plus 6p, that's correct, just double checking. So here I wrote a 6 there. The original problem here, this was a p plus 5. Okay, so this is going to still be over here a p plus 5. I haven't done anything with that. Okay. So now let me think about this. I'm going to add the p squared over. I'm going to minus 1 from both sides. So that's now going to be, actually first let me subtract my 6p from both sides. So that's going to be a negative 5p. Then I'm going to minus 1 and I get a plus 4 equals 0. This is factorable. This is going to be p minus 1, p minus 4 equals 0. So when I solve that, I'm going to get p equal 1 and p equal 4. Now, something that we want to check is restrictions, which we did at the beginning of the chapter. We haven't really emphasized as much now, but when I get a p equal 1, I need to make sure it does not make any of my denominators 0, and it doesn't. And same with my p equal 4. So those are going to be my answers because none of them made my denominator 0. If it made my denominator 0, that would just not be a solution. Okay, number 10, similar idea on this. Let me first rewrite it. 1 over x times x plus 2 plus x minus 1 over x equals 1. So what I'm going to do is I'm going to take this And I'm going to multiply everything by an x and an x plus 2. By an x and an x plus 2. By an x and an x plus 2. Everything. Because I want to get rid of all of my denominators. So when I do that, this x and x plus 2 get rid of this. And I am left with 1. Over here, this x and this x cancel. And then let me just write this out first. I'm going to have an x plus 2 times an x minus 1. I'm going to work that out in a second. And on the other side, I'm going to end up with an x times x plus 2. Okay, so let me clean this up. So I'm going to have a 1 plus x squared plus x minus 2 is equal to x squared plus 2x. When I subtract x squared from both sides, well, let me first clean up. This is going to be an x squared plus x minus 1. I'm going to minus x squared from both sides, and they cancel out. I'm going to minus x from both sides, and I'm going to negative 1 is equal to x. And that's my answer as long as it does not make any of my denominators 0, and it's not going to make any of them. So this is an answer. These ones won't be on the test, maybe as an extra credit, okay? But not as a main problem. Number 11, system of equations. I'm going to number these number 1, number 2, number 3. Looking at these, I want to focus on my variables. I have an x, a 2x, and a 3x. I could eliminate easily. Let's just see if anything else is either positive y, negative y, and a negative 2y. That's pretty easy. My z's are actually not so bad either. So really it's up to you as to which one you're going to do. I think I'm going to do the y's. Okay, I think I'm going to eliminate y. So that means I'm going to be left with an equations with x and z's. So I'm going to take equation 1, x plus y minus z equals 0, and equation 2, 2x minus y plus 3z equal a negative 4. And I'm going to add those two equations together. And I end up with a 3x, my y's cancel out, plus 2z is equal to negative 4. I'm going to call this equation 4. I am now going to take equation 3, which is 3x minus 2y minus z equal negative 13. I am going to use, I think I'm going to use equation 1. And what I'm going to do, I'm going to write it up here. I'm going to use equation 1. And I'm going to multiply equation 1 if I'm trying to get rid of my y's by a 2. Okay, that whole equation I'm going to multiply by 2. So when I do, I'm going to get a 2x plus 2y minus 2z equals 0. So now I'm going to add these two equations together. I get 5x, my y's cancel out, negative 3z is equal to a negative 13. That's going to be equation 5. So I'm going to be solving this system, okay? So looking at this, let me just take a peek here. I've got a 3x and a 5x. I'd have to try to get a 15. And I have a 2z and a negative 3z. I think I'm going to do my z's. Okay, so now I'm going to solve the system by trying to eliminate my z's. So I am going to multiply equation 4 by a 3. And that's going to give me 9x plus 6z is equal to negative 12. I'm going to multiply equation 5 by a 2. And that is going to, so equation 5, yeah, by a 2. So that's going to give me a 10x minus 6z equals a negative 26. I'm going to add those two equations together. I get a 19x is equal to a negative 38. I divide by 19 and I get a negative 2. So my x is negative 2. Now I'm not quite done solving this system. And when I say solving this system, I'm talking about this system right here. Okay, that had two variables, an x and a z. I found my x. I still need to find my z. So I'm going to go into, I think equation 4 is the one I'm going to plug into. So I'm going to put it into equation 4. And so I'm going to have 3 times negative 2 plus 2z equals negative 4. So negative 6 plus 2z equals negative 4. I'm going to add 6 to both sides. I get a 2. So I get z is equal to 1. At this point, I have found my x and my z. I need to find my y. So I'm going to go to equation either 1, 2, or 3 to find my z's. Let's say I go to equation 1. So equation 1, let me just write it here so I see it, was x plus y minus z equals 0. So now I'm taking both of these and putting them here. So I'm going to get negative 2 plus y minus 1 equals 0. So negative 3 plus y equals 0. I end up with y equaling 3. Now we write these as a point. Always your x first, so negative 2, your y, which is 3, and your z, which is 1. On number, so for 12, what we're going to do is we are going to substitute in our 3 points into this equation here. Y equal a x squared plus b x plus c. That's standard form for a parabola. I'm going to get 3 equations. First equation is going to be when I'm going to be working out negative 1 comma negative 5. I'm going to put that into the equation. I'm going to get negative 5 is equal to a times negative 1 squared plus b times negative 1 plus c. And that is going to clean up to negative 5 is equal to, and remember, negative 1 squared, that is going to be a positive 1. So that's going to be a, oops, let me get back to pink again. A minus b plus c. Now, equation 2, I'm going to be putting in 2 comma 1. So I'm going to get 1 is equal to a times 2 squared plus b times 2 plus c. And that ends up giving us 1 is equal to 4a plus 2b plus c. On number 3, the third equation, the third point, 3 comma negative 5, I'm going to get negative 5 is equal to a times 3 squared plus b times 3 plus c. And that ends up giving us a negative 5 is equal to 9a plus 3b plus c. I, on these problems, like to eliminate my a's because, my c's, I apologize, because I'm going to get a c in each of those 3 equations. So I can just multiply one of the equations by negative 1. And the equation I think I'm going to multiply by negative 1. I think I'm going to do this equation by negative 1. So I'm just going to write number 1 here. And I am going to be multiplying it by a negative 1. And so when I do, let me just write it, -5 is equal to A minus B plus C. I'm going to get as my new number one, positive 5, because a negative times a negative, is equal to -A plus B minus C. So now I'm going to take that equation, and I'm going to be using that equation with number 2. So let me just use number 2 here. I'm just going to draw a line in between. Okay. So I'm for number 2, I'm going to have 1 is equal to 4A plus 2B plus C. I'm going to use my multiply by -1, number 1. So I'm going to have 5 is equal to -A plus B minus C. Add these up, end up with 6 is equal to 3A plus 3B. I can divide by 3, but I'm going to wait a minute and see if that's something I want to do or not to simplify it. So now I'm going to take number 3, and I'm just going to scooch this over. So now I'm going to take number 3, and I'm just going to box this. This was from my last problem. Okay, so number 3. Which is a -5 is equal to okay. So -5 is equal to 9A plus 3B plus C. And I'm using equation 1. And equation 1, 5 is equal to -A plus B minus C. Add these two equations together. And I'm going to get 0 is equal to 8A plus 4B. So looking at these, this one here, I'm going to call equation 4. This one here, I'm going to call equation 5. I'm going to divide this one here by 3 and 3 and 3. And I end up with 2 is equal to A plus B. The other equation, I'm going to divide everything by 4, and I'm actually going to divide it by a -4. Because when I divide it by a -4, I'm going to get a -2A minus B. And then that's going to be helpful when I'm trying to solve this. So now I am going to have 2 is equal to A plus B, and 0 is equal to -2A minus B. I'm going to use those two equations. So right now I'm going to take this equation and put it right here. So I have 0 is equal to -2A minus B. I add these up. I get 2 is equal to -A. So -2 is equal to A. Then I'm going to take that -2, and I'm still not done solving this new system here. So this system, I have this 2 is equal to A plus B, and this 0 is equal to -2A plus minus B. I found my A, but I need to find my B. So I'm going to take this -2 and put it into number 4 here. Okay, so I'm going to plug it into number 4. And so when I do plug it into number 4, I'm going to get 2 is equal to -2 plus B. So I'm going to add 2, and I get 4 is equal to B. So once I have these, okay, my A and my B, then I can look up at the top equations and figure out which one I'm going to put this in to find my C. And maybe I'll do it to number 1, okay? So I'm now going to take both of these, and I'm going to put them into equation 1, which is -5 is equal to a, which is -2, minus b, which is 4, so -4 plus c. So I get -5 is equal to -6 plus c. I get 1 is equal to c. Now we're doing this to try to get an equation of a parabola. So that equation is going to be -2x squared plus 4x plus 1. And that's going to be our equation. On number 13, we're going to solve this system. Now this system, if I call this one equation 1, this equation 2, and this one equation 3, each of these has 2 variables, but they all have a different pair of variables. So I'm going to look at which one I would rather eliminate. Okay, my x's, I have a 2x and a 3x. Let's see what happens with my y's. I have a -5y and a 2y. Neither of those seem like I want to do either one. So if I'm looking at my z's, I notice that I can add those together and they're going to cancel out. So I'm going to eliminate z. And if I eliminate z, that means I should get 2 equations with x, get an equation with x and y. So what's going to happen is this equation right here that has x and y, and I've already eliminated a z, that one I'm going to keep, okay, because z is eliminated already. Okay, so I'm going to take equation 2, which is 2y minus z is equal to 4. And equation 3, which is, and I'm going to, hold on, let me space it out a little better. I don't have any x's, so for my number 2 equation. So I'm going to give myself some space. And then I'm going to have my 2y minus z equals 4. My purple one, I have a 3x plus z is equal to 17. My z's are going to cancel out, so I'm going to get 3x plus 2y is equal to 21. So that is going to be my equation 4. And so now I'm going to take equation 4 and equation 1. Okay. And that's the system I'm going to solve. So let me just write that here. So equation 1 is 2x minus 5y equal -5. Equation 4 is 3x plus 2y equals 21. I'm thinking I'm going to try to eliminate my x's. So I'm going to multiply one of these by a 3, one of them by a 2, and one of them I'm going to make negative. Let's say I multiply this one by a -3, and I multiply this one by a +2. So my new equation 1 is going to become a -6x plus 15y is equal to 15. My new equation 4 is going to become 6x plus 4y is equal to 42. Add these 2 equations together. My x's cancel out. I get 19y is equal to 57. And y is going to be 3. So now I still need to solve that system. So I am going to find my x by plugging it into, let's say, equation 3. So in equation 3, I'm going to have 3x, not equation 3, sorry, it's a y, into equation 2. Let's see, so, or sorry, I'm looking at the wrong ones. I've got equation 4 here, or equation 1. So let's just say I put it into equation 4. Okay, so if I put it into equation 4, I'm going to have 3 times x, so I'll just write as a 3x, plus 2 times y, which is 3, equals 21. So I get 3x plus 6 equals 21. I get 3x is equal to 15, so x is equal to 5. Now, I need to find my z, and I can do that by substituting it into any of these. Let's say I substituted into number 3. Okay, doesn't matter which one. Let's say I put it into number 3. And actually, if I'm putting it into number 3, I'm going to be substituting this. So in 3, I'm going to have 3x, which is 3 times 5, plus z equals 17. And when I'm doing that, I'm going to get a 5x plus z equals 17. So z is equal to 2. So then my answer, my point of intersection, is going to be my x, which is 5, my y, which is 3, and my z, which is 2. For number 14, okay, equation 1, I'm going to be plugging in -3, 2. So I'm going to get 2 is equal to a times -3 squared plus b times -3 plus c. And that ends up giving me 2 is equal to 9a minus 3b plus c. Equation 2, I have a -2, 0. So I'm going to get 0 is equal to a times -2 squared plus b times -2 plus c. So I get 0 is equal to 4a minus 2b plus c. And equation 3, I have a 1, 6. So I'm going to have 6 is equal to a times 1 squared plus b times 1 plus c. So that's going to be 6 is equal to a plus b plus c. And this is going to be the system that I'm going to be trying to solve. So looking at that, I'm going to try to eliminate my c's in each of these. And I think I'm going to multiply the bottom equation, number 3, by a -1. So when I do that, I'm going to get -6 is equal to -a minus b minus c. So this is the equation 3 I'm going to use. So I'm going to use that with equation 1. So when I use it with equation 1, I get 2 is equal to 9a minus 3b. 9a, let me just get the a further away. 9a minus 3b plus c. Equation 3 is a -6 is equal to -a minus b minus c. When I add this together, I end up getting a -4 is equal to 8a minus 4b. And that's going to be equation 4. Now I can divide everything by 4, but let's see what happens with the other equation. So the other one, I'm going to be taking number 2. I am going to be having 0 is equal to 4a minus 2b plus c. I'm going to take my 3, which is a -6 is equal to a -a minus b minus c. Add those two equations together. Get -6 is equal to 3a minus 3b. This I'm going to call equation 5. Now, both of these equations, this one here and this one here, that's the system I'm going to solve. In both of these cases, I'm going to divide to simplify. So for this one, I think I'm going to divide this by 4 by 4 by 4. So when I do that, I am going to get -1 is equal to 2a minus b. For 6, I'm going to divide by 3, but I think I'm going to divide by a -3, because if I divide by a -3 for equation 5, I'm going to get 2 is equal to -a plus b. And now my b's will cancel out. Now I'm going to get 1 is equal to a. So I know my a is equal to 1. I'm going to substitute that back into the equations. So let's say I do it into number 5. So I'm going to get 2 is equal to -1 plus b. I am going to add 1, so I get 3 is equal to b. And now I think I'm going to go back up to the top. And the equation I'm going to use, I think, is this one here, number 6. I'm sorry, number 3, but with the 6. So I'm going to plug this into number 3. So I'm going to have 6 is equal to a, which is 1, b, which is 3, plus c. So 6 is equal to 4 plus c. So I end up with 2 is equal to c. So now I'm going to take those 3 and substitute them in to get my equation, which is going to be y is equal to a, which is 1. So that's just going to be x squared, plus b, which is 3. So 3x plus 2. And that's the end of this video.